You can see this blinking. This is the aromatic region. Just I am giving the overview. This is the aromatic region. Okay, you have to if you are knowing the spectroscopy, then you can easily understand. This is the aromatic region, and in depth 135, all CS2 will come below this line. So you can also easily determine the how much CS2 in your molecule. After that, this is the proton spectra. How to identify? This is the proton. This is the NH proton. It will be B-shielded. This is the CS3 proton. And this is the example of 2D spectra. HS heteronuclear, heteronuclear correlation bond spectroscopy. It shows HSQC shows that which carbon attached to which hydrogen. What is the environment of that any carbon around the carbon? So how this is the 2D spectra HSQC 2D spectra. You can see this side we plot the carbon spectra and this side we plot the proton spectra. After that, you can see this cross. When you are draw a line from this you can meet here. So you can say that this proton or this carbon connect to this proton. And same thing in HSP multiple bond correlation also. You can determine the surrounding of the carbon atom. So this is another example: bioactivity guided extraction of isolate antipsychotic agent from the leaf of Rauwolfia tetraphylla by FCPC. Same things. First, we have to carry the extraction and fractionation, and we also tested the activity of this plant material. And you can see the mixture of how much alkaloid 1, 2, 3, 4, 5. There is a 4th alkaloid you can see in the TLC plate, and same you can see in the HPLC chromatogram also. The same we have applied this material to FCPC. This is the mixture of 5 to 5 alkaloid. You can able to get by this technique 4 alkaloid. There is the 10-methoxy tetrahydroelastone, isoreserpine, alpha-amine, and reserpine with 97% purity, 97% purity, and 95% purity. Very easy. In 4 hours, you can get the result when you finalize your solvent system. So now you isolated your compound. Okay. Now you well established the structure. Okay. Now it is known as a marker compound. So how you will do this marker compound? The 2 things you can do. The drug development, it will be used in the drug development, that is the SR and QSR, structure activity relationship and quantitative structure activity relationship. But these things is not our mandate. Our mandate is this marker based standardization and assay method, development of validated analytical method for herbal drugs. So now coming on the TLC and HPTLC. In TLC, there is some troubleshooting. I am going to discuss. You can see that the running TLC on the graphics image. In TLC system, sometimes streak. First, I'm discussing the trouble of coming in the TLC when you're developing any TLC. Streak and not spot. It means too much sample. You should dilute your sample. When getting the spot smeared out. Okay, F smeared. Then it means your compound is acidic or basic. So your compound may be your alkaloid or any acidic group. So when you are putting the TLC, it get ionized. So we have to prevent the ionize. So when it get the ionized, it will be not your result will not reproducible. So we have to prevent the ionization of the any compound. So how you prevent the ionization? So we have to use ion pairing agent. Ion pairing agent that is the formic acid, ammonia, and acetic acid. You use an additive in the eluent. So you can use the ammonia and trifluoroacetic acid, formic acid. These are the ion pairing agent. Some crescent said the silica is disturbed during the spotting. Curved solvent from the front with the spot out of the lane, plate is touching side of the container, and many of the spot and stripes origin marked in the pen. Sometimes you will see the blue ink. So what happen? What we do? We spot use the sometime pen. Okay, on TLC plate. So you can directly see in UV some blue spot. So always avoid the using the pen. Always use the pencil, so that pencil is not eluted with the solvent system. No spot on plate. Sample is too diluted. Wrong visualization. So there is some difference of HPLC, the HTLC and HPLC. In HPLC, the particle of HPLC is more fine, that is the 5 to 6 micron, and in TLC 10 to 12 micron. And the thickness is also less in HPLC plate rather than TLC plate. These are some common solvent system. If you don't know what solvent we have to apply, then you can if you're totally unknown about the plant material, then you can start with the some non-polar compound to high polar. And if you're knowing that this plant contain some polar compound, some alkaloid, then flavonoid, then these are the some solvent system. First you can apply. After that, you can accordingly you can modify the solvent system. Like the polar compound, anthocyanin, arbutin, alkaloid, cardiac glycoside, bitter principle, flavonoid. You can use ethyl acetate and methanol. Accordingly, by seeing the plate, you can modify your solvent system. For in case of alkaloid, toluene, ethyl acetate, dimethylamine, always better. And in case of saponin, chloroform, glacial acetic acid, methanol, and water, and coumarin, diethyl ether. Like this, some essential are toluene, ethyl acetate. The essential is very non-polar component, so toluene ethyl acetate is best solvent, and you can get the good separation. In case of triterpene, ethyl acetate, toluene, formic acid, composition of 550 to 5 and 15 ratio, you can use toluene, chloroform, methanol. And after that, after seeing the plate, you can use acid and base modifier. Acid modifier is acetic acid, formic acid, and base modifier diethylamine and ammonia. The stepwise practice of HPTLC. In HPTLC, the software activation, after that application on the plate, chromatographic development, image documentation, densitometric scanning, and derivatization and image documentation in scanning. These are the some part of HPTLC: applicator, developer, and scanner, and photodoc. The regulatory acceptance of HPTLC. In USP chapter 3 and USP chapter 6 to 9 in our Ayurvedic Pharmacopeia and API, already the HPTLC fingerprint included. So this is the regulatory acceptance of HPTLC. Now there is some emerging tools like 2D TLC and HPTLC MS. And 2D TLC, what is the 2D TLC? 2D TLC, two-dimensional TLC. First, when you are running your plate in vertical direction, after that you rotate your plate in 90 direction, so that you will get like this plate. It is a better separation. For some time there is a very complex mixture, enantiomers and stereoisomers. You are not getting separate in the TLC plate. Then you can use the 2D plate. It is nothing, just rotate your TLC. First is one spot over there. After that, upward direction, and you rotate your plate like this. You rotate in 90 direction. After that, again you run in solvent system. Then you will get the like this separation. And that is the 2D TLC in 90 direction in visual in that graphics you can see here. And another is emerging tool is HPTLC MS. HPTLC MS is used to identify the spot directly. If you are having the 5 spot, okay, and 2 and 3 spot, and the MS having the data in their library, then you can easily identify the spot on TLC plate, the which compound and which marker compound on the TLC plate. So this interface, this is the mass interface. When this mass interface connected to HPTLC direct. So what happen when your spot what it will do, interference, it will be scan your spot, whatever your targeting spot, what happened? It scan your spot. After that, uh, after that you can see here. Okay, one needle will come with solvent system. It scratches the spot, and after that it sent to the MS, and MS analyze the data, and you can see here this spot is this compound. So you can easily get the MS spectra by HPLC MS. So this is the interface in hyphenated techniques. Okay, when it connected with the HPLC, so you can direct get the spectra of any compound. So if you are having the library, if your HPLC having the library, then it will be directly match which spot and which one is marker compound, and it belong to which group of compound. Acceptance of criteria in TLC in pharmacopoeia. What is the acceptance criteria? You can see the travel length should be 8 centimeter in pharmacopoeia, and from the bottom, when you are applying the spot, it should be 10 mm. This length, and the spot should be 10 mm. The band length should be 10 mm. And the distance between two spot, okay, on TLC plate, center to center, 11 almost 11 mm. Okay, this is the acceptance criteria. And in pharmacopoeia, you will never see the spot. You will always see in the band. So it is better to apply the band because you will in band it is a uniform, and you will get the better separation, and it is easy to estimate any compound. This is the acceptance criteria of TLC in pharmacopoeia. So in TLC normal phase, this is the mechanism inner side. What happened in this is the non-polar silica gel in TLC. TLC non-polar silica gel. So in non-polar, the thumb rule of chromatography is dissolve like dissolve. Okay. So in the non-polar TLC, there is a normal phase TLC. It is a more affinity with non-polar compound. So what happened? The polar compound will elute first. This is the polar compound which is going the first, and this is the having affinity with the, because this is the non-polar compound having affinity with the stationary phase, because this is the stationary phase also non-polar, and this compound is also non-polar. So it will be elute slower. So by this interaction, you can get the separation in this TLC. That this is the graphics image. You can see in up band it is a very polar. It is a non-polar compound. Okay, in lower you can see mid-polar compound, and in the bottom you can see the high polar compound in the normal phase TLC. In what happened inside the silica gel? There is many interaction happened. There is the hydrophobic interaction, hydrogen bond interaction, and bond ionic interaction. By this interaction, we are able to the compound distribute itself between two phases. One is stationary phase, that is the silica gel, and another is mobile phase. Mobile phase, any mobile phase, there is a mixture of mobile solvent, and it should be single solvent system also. So in this graphics, you can see this is the non-polar stationary phase. Okay, the polar compound eluted faster, and non-polar compound is going very slow because it has strong affinity with the stationary phase. HPLC and HPLC. There is some limitation. Every technique having some limitations. Okay, HPLC, the sensitivity is less than HPLC. Okay, in HPLC there is the high accuracy, high sensitivity, and but in HPLC you cannot get that much sensitivity. But in HPLC, but in HPLC is very cost effective. Okay, and there is a no gas required, and there is a solid in both conditioning phase. Both इसमें required नहीं है HPLC में. There is no required of conditioning. Okay, in HPLC gas is required. Okay, result by machine, both are and resolution very high. In HPLC, you can get the resolution very high, and in HPTLC, you can get the moderate resolution. This is the one TLC. Okay, you can see the spot on TLC plate. 1, 2, 3, 4. 4 spot you are seeing. Okay, these two are the marker compound. And the same compound, the same sample you can apply when HPLC. How much compound you can see? 1, 2, 3, 4, 5. Any the separation is the resolution is better and separation is very high in HPLC. Okay, in comparison to HPTLC. But HPTLC is very cost effective, easy to use, and there is no very complex sample preparation in the HPTLC. So some analytical method for validation of performance of characteristic method validation. If you are going to method validation, then precision, you have to take care of precision, accuracy, limit of detection, limit of quantification, specificity, linearity, range, and robustness, and system solubility. As per the ESP and ICH guidelines, they set some parameters. By using these parameters, you can develop any method, validated method for the any plant material, any marker compound. In accuracy, okay, accuracy and precision. What is the accuracy? Accuracy means closeness of result toward the true value. That is called the accuracy. And in precision means repeatability. Again, you are analyzing your sample and you are getting the same result. It means your method is precise. In LOD, limit of detection, you can determine by plotting the calibration curve. The development of HPLC method by quantitative determination of bioactive alkaloid lysosol and calclomin Ayurvedic muricata. Okay, this is the column water sperozole OSD column. This is the mobile phase 0.01 phosphate buffer and containing 0.1 glacial acetic acid. And this is the gradient illusion. A detection is 254 nanometer. This is the two marker compound. Okay, this is the plant material, and by using two marker compound, we developed the HPLC method. This is the some parameters: RF value, concentration, regression, correlation coefficient, accuracy, precision. Okay, limit of detection and limit of quantification. As per the ICH guideline, we have taken care of all parameters. Okay, this is the quantitative estimation of lysosol. Okay, a hot extraction and for 15 minutes, hot extraction for 30 minutes, cold extraction and ultrasonic extraction. Ultrasonic extraction 30 minutes. You can see ultrasonic extraction is best extraction technique. For 30 minutes, you can get the higher content of lysosol, 0.39% lysosol and 0.112 kynoglobin. So we estimated these two marker compound in the Ayurvedic muricata seeds. This is the another HPTLC method development HPTLC method for the Estonia sclerosis using the 4 marker compound. 4 marker compound: ursotic acid, betulinic acid, beta cytosterol, and lupeol. These are the 4 marker compound we used to estimate in the Estonia scolaris, that is known as Saptaparni. HPTLC plate. Okay, this is the 4 marker compound, and this is the plant material. The 3 B and C and D. The mixture of 4 marker A is the mixture of 4 marker compound. Okay, UA denoted as a ursotic acid, and BA denoted as betulinic acid, and cytosterol is SL denoted as SL. After that, in B and C and D HPTLC program of methodologic structure of A scolaris, stem bark, root bark, and leaves. In 3 parts, we are estimated that these 4 marker compound. You can see in stem bark, ursotic acid 0.133%, in betulinic acid in stem bark 0.0992%, in beta cytosterol 0.0776%, and root bark you can see here 0.1% around 0.01%, betulinic acid, and 0.1% around beta cytosterol, and lupeol 0.1%. In leaves, we are not detected, ursotic acid not detected, and betulinic acid also not detected. But in beta cytosterol, there is a nominal amount of beta cytosterol 0.05%, and 0.68% LPL. This study also published in Journal of Chromatography, Journal of Planar Chromatography. Another is HPLC method of determination of ursolinic acid in various Ocimum species. Various Ocimum species, that is the Ocimum gratissimum, Ocimum sanctum, and Ocimum basilicum. Okay, and Ocimum basilicum. This is the ursolinic acid marker compound. Okay, this is all the parameters we have taken care. Okay. A is a Ocimum gratissimum, B is a Ocimum gratissimum, and C is a Ocimum sanctum, and D is a Ocimum basilicum. So this is the content in determine Ocimum gratissimum. The ursolinic content 0.74% by HPTLC, and Ocimum sanctum, the ursolinic acid containing 0.5%, and Ocimum basilicum 0.056%. Now coming on the aflatoxin. Aflatoxin in available pharmacopoeia method, there is a visual method for determining the aflatoxins. Okay. So this is the limit of determining the aflatoxin in pharmacopoeia. B1 should not be more than 2 ppb, and the mixture of B1, B2, G1, G2 should not be 5 ppb. What is the aflatoxin? Aflatoxin are naturally occurring fungal toxins that were first found in the fungal Aspergillus flavus. Okay. Out of these aflatoxins, okay, these are the structure of aflatoxin. The aflatoxin B1 is considered to be the most toxic for the human health, but in addition to the aflatoxin B2 and B1, in comparison of B2, B1, and G1, and the B1 is more toxic. Okay, so in TLC you can visualize your aflatoxin. Okay, but for determination of estimation of aflatoxin, you have to use HPLC or UPLC. This is the one example determination of aflatoxin B1, B2, B2, G1 by HPLC and UPLC. Okay, this is the in determining the aflatoxin. That simple preparation is very important. Simple preparation is very important. First, you have to clean up your sample. Okay, by putting the sodium. This is the immunoaffinity column. Immunoaffinity column. Okay, when you are putting your material in this column, what happens? This is the antibody. Okay, interact with your.
Sorry for the interruption, sir. We are running short of the time. Can we please wind up the session soon?
Hello, yes, ma'am.
Sorry for the interruption, sir. We are running short of time. Can we wind up the session soon?
Okay. I will take 5 minutes only, ma'am. 5 to 10 minutes.
Sorry, sir.
Okay. Then what happen? It will be interact with the antibodies, or remaining material wash out. After that, you can easily elute by using the any solvent system. So you can enrich, you can clean up your sample for analysis of aflatoxin material. Then you can apply the HPLC. Then you can get these 4 peak B1, G1, B2, and G1, and you can estimate easily by using the reference compound of aflatoxins. After that, you can also use COBRA. This is the HPLC method for aflatoxin determination. Now coming on the gas chromatography. So difference with the gas chromatography used to determine the volatile component in oil and pesticide analysis. Liquid chromatography, soluble compound in the polymer, water purification. Okay, and gas chromatography, volatile mixtures, gas toxins. It uses room temperature and sufficient. High temperature is necessary in the gas chromatography. Liquid solvent determined by the sample polarity and solubility. Kaya gas, inert or unreactive, determined by the method of detections. So in fast analysis of pesticide residue in the sample of using GC/GC-MSMS. So there is a Quecher method. Quecher kit is coming. Quecher means quick, easy, and cheap, effective, and rugged and safe method. Okay, this is the acronym, and then Quecher, and Quecher means quick, easy, cheap, effective, and ruggedness. The Quecher kit, there's a simple treatment kit. Okay, you have to first clean up your sample. Okay, you can see the no cleanup is required when you are putting your sample in Quecher. Then you can get the clean sample, and after that you clean sample, you can apply on the GC/MSMS. Okay, GC/MSMS, you can determine the level of pesticide analysis sample. This is the permissible limit in pharmacopoeia of pesticide. There is a 34 type pesticide available. In pharmacopoeia, we have to analyze in our any Ayurvedic sample or any herbal samples. There is some ICP OES method for determination of heavy metal, mercury. This is the some limit of 4 marker compound in pharmacopoeia: mercury, cadmium, lead, and arsenic. The permissible limit in mercury 1 ppm and cadmium 0.3 ppm and 10 ppm and 3 ppm. Okay. You can see here. This is the one. This is the ICP-OS. It inductively coupled plasma optical emission spectroscopy. When you are nebulize your sample, the temperature 11,000 degrees Celsius, you can some light is emitted and it will be detected by the machine. You can easily identify these 4 heavy or toxic metal. Apart from this metal, you can also a number of marker compound available in periodic table. You can also estimate that element by the ICP-OES. This is some inner working of ICP-OES. You can see the molecule, any metal when excited, it will be in touch with the plasma. It will be excited. After that, it emits some light. It emits some light. Okay, and it will emit some light in a form of photon. After that, it will pass from the photon, and you can get the spectra here of any metal analysis by the ICP-OES. This is the measurement ICP-MS. You can determine ICP-MS for elemental impurities for heavy metal analysis. You can go up to the 1 ppb. Okay, in ICP-OES you have to PPT level. In flame AS you can also go up to the 1 ppb or up to the somewhere PPT level. After that, another technique, that is the NIR, near infrared spectroscopic technique. In this technique, there is no sample treatment is required. Okay, directly you put your sample on the machine. Okay, directly you can get the NIR spectra, because penetration power of the NIR is very high. This is the 27 cultivated and wild sample. You can see all the spectra is matching. It means your sample is it is for preliminary screening of the any plant material. This is the plant powder, just directly put, no sample treatment is required, no solvent is required, just put on the probe of the machine and you can get the spectra like this. This is another one. This is a TLC of 2 Korean samples. Okay, this is the Delurucine. The same plant sample collected from the Korea and Chinese. Okay, in Korea you can see this marker compound. This marker compound, the decoricine. Okay, but in Chinese sample you cannot see this hump in the Chinese sample. It means this compound is absent in Chinese sample. So it is a very fast technique that is known as a near infrared spectroscopy for screening of any plant material. This is how to reach. This is the PCIM index, director PCIM index. This is our website. We are also available in Twitter, Facebook, and YouTube. Thank you very much.
Thank you so much, sir, for the wonderful session, for that informative and useful choice.
Dr. Saab, thank you very much. It was a very informative talk. And let us try to meet in person as soon as possible.
Okay. Thank you, sir.
Yeah. Thank you, Dr. Saab.
I think I hope I explained.
No, it was really well. Everything in detail. It is very useful for the delegates. Thank you so much.
Okay. If you are anybody having question, then it can be direct.
Yeah, sure. Definitely. I'll share your number so that they can communicate.
Okay. Thank you
so much. Thank you.
Okay. Thank you.